This is another video in the series from Math 1073 for UTSA. Today we'll be talking about Module 3.2, quadratic functions. The first problem says, for the following exercises, rewrite the quadratic function in vertex form and give the vertex. So the vertex form for a quadratic function goes like this. Y equals a times x minus h squared plus k. And h comma k, this is the vertex. And there are two ways to do this kind of problem. I'll show both. Well, I'll show the first one the long way. And the second one, I guess I'll show, well, we'll do the first one the long way and then I'll figure it out as we go. So looking at this one's relatively easy. I'm going to do something called completing the square. What I'm going to do is focus on these two terms and think, okay, if I got to change this last number and pick what it was, what would I change it into so that this factored nicely? So if this could be anything I wanted, ignore it temporarily. What would be nice to have? Well, the shortcut is take this number, cut it in half, and then square the result. So half of 2 is 1, squared is 1. Why is it cut in half and then square it? Well, this is somewhat complicated. I think that'd be better explained in the live lecture rather than in the video. And it's probably in the textbook anyway. So what I'm going to do is I'm going to go ahead and put a +1 there. But so that I'm not really changing what I have, I'll put a -4 after, so that this is really still -3. Now I can factor this and get x plus 1 squared minus 4. And you might be a little bit worried, oh, I have to factor also? Well, this number is always half of this number, so you don't really have to work out the factorization. You just take half of that number, okay? So if I rewrite using the format x minus h, I need to have a minus here. So I need to treat this like a double negative. So this is x minus -1 squared plus -4. I have a plus here's part of the format, so I want to write it that way so it's clear as possible. So these two numbers make up my vertex, okay? This is, oh, you might wonder about the a. In this case, a is 1. It just, we didn't need to worry about it the whole time. So the vertex is -1 comma -4, okay? Now there is a formula for this. We'll go ahead and do the short way with this example. We won't wait until the next example. If you remember from the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a, right? There's some symmetry in the quadratic, the way a parabola, the graph of a parabola works. We haven't gotten to graphs yet, so the reason for the symmetry is something we'll have to talk about later. But there's a visual reason for this, what I'm about to do. If you throw out the plus or minus square root part, then this formula gives you h. Okay, so h equals -b. Well, a is 1, right? Let's put it there. A is 1, b is 2, c is -3. So -1 over, oh, sorry, -2. -2, that's b. I just got done saying it. -2 over 2 times 1. This is -2 over 2, which is -1. Hey, that's what I found down here for h. So you don't have to do this completing the square process. You can just use the quadratic formula to get whatever h is. But once you find h, if you haven't done this, how do you know what k is? Well, k is the y-coordinate of the vertex, and h is the x-coordinate of the vertex. So in order to find k, you just throw h back into the function. Okay, so this will be -1 squared plus 2 times -1 minus 3. So I get 1 minus 2 minus 3, which is -4. There you go, -4. So instead of doing this procedure, you can do this one instead, and it gets you the same result. The reason these are connected is basically that the reason that the quadratic formula works is because of completing the square. I don't typically present that in class, so if someone asks, we can do it in the live session, but I'm going to leave it alone because it's pretty tedious. Most students kind of check out halfway through or worse. So we'll leave that for a live session if anyone asks. anyway, let's go do the next example, and we'll do the shortcut version. Okay, so we'll find the vertex first, and then we'll write out the vertex form. I'll go ahead and copy the vertex form up here while we're at it. And the a is always the this coefficient, right? Which is 1 in this case. So h, this is negative b over 2a. So negative, negative 4. Oops, negative, negative 4 all over 2 times 1. So I get 4 over 2, or 2. So h is 2. So k, this is g of 2. Okay, so this is going to be 2 squared minus 4 times 2 plus 13. So 4 minus 8 plus 13, which is that 9? 9. Pretty sure that's right. 4 minus 8 is negative 4 plus 13 is 9. So the vertex is 2 comma 9, which means that the vertex form is y equals 1 times x minus 2 squared plus 9. Okay. So let's look at the next one. For the following exercises, determine whether there is a minimum or maximum value to each quadratic function. Find the value of the axis of symmetry. Okay, so we got some extra room up here. So whenever a, that leading coefficient, is positive, your graph is going to open up like this. So it will have a low point on the graph. The vertex is at the bottom of the graph, essentially. Whenever a is negative, then your graph is going to look like this. It will have a high point, so the vertex is the highest point on the graph. It's at the top of the graph. That's what this is referring to. So for this one, that leading coefficient is negative. A is equal to negative 1. So the graph opens downward like this. So this one opens down. Is that the phrasing that was used here? It didn't, but that's fine. Opens down. The terminology in this exercise, I'm sure, is to match the terminology of the web work assignment. So that means that there is a maximum. Okay. Now the value of the axis of symmetry. Okay, so going back to the graph, I guess I could do it here. The vertex is right here, right? So the axis of symmetry goes through the graph like that. So that means that the x-coordinate of the vertex is the location of the axis of symmetry. Essentially, h is what's being asked for. So h equals negative b over 2a. So negative, negative 8 over 2 times negative 1, because a is negative 1 in this case. So I get 8 over negative 2, so I get negative 4. So negative 4 is the x-coordinate of the vertex, and also this is where the vertical axis of symmetry is, basically. Okay, let's go to the next one. And notice that the other coefficients, I'm sorry, this last coefficient doesn't affect this. The negative 15 affects the verticality, where is the graph positioned vertically, but it doesn't affect whether it opens up or down, and it doesn't affect where the axis of symmetry is. Okay, over here, basically the same thing. Or the same, I mean, we're doing the same question, not the same thing. The result is different. Well, a is positive, so this opens upward. Right, so the graph looks like this. So it has a minimum. And to look for the axis of symmetry, well, h equals negative b over 2a. So negative, negative 5 over 2 times 4. So 5/8. So that is where the axis of symmetry is, 5/8. Okay. What's next? For the following exercises, determine the domain and range of each quadratic function. Yeah, so basically, if the graph opens upward, if it has a low point, then the y-coordinate of the vertex is where the range starts. The domain for a quadratic is always all real numbers. So really, this is about the vertex again. So whatever k is, if you have an open upward, this one opens downward. Let's pretend I didn't. Yeah, don't tell anyone. Let's pretend. So this one opens downward, right? So the range is the output, the vertical values, right? So this will be negative infinity up to whatever k is, including k, actually. And then for this one over here, this will be from k to infinity, whatever k is, okay? Is that what we're finding? Yeah, domain range. Okay, so the domain for both is just all real numbers. So let's work out what k is. So h equals, oh, you know what? This one's already factored for us. H is 2. I'm sorry, k is 2. My mistake, sorry, k is 2. So that means that the domain is negative infinity to infinity, all real numbers, and then the range is negative infinity up to 2. Okay. For this one is not already in vertex form, so I do have to find out h first. So h equals negative b over 2a. So negative 5 over 2 times 2. So 5/4. Okay. So k, this equals g of 5 over 4. 5 over 4. Or if you want, 1.25, but I'm going to use fractions. So 2 times 5 over 4 squared minus 5 times 5. I keep wanting to put the 4 on top. Why is that? 5 over 4 plus 6. So I get, let's see, 25 on top, 50, well, 50 over 16, I suppose, which is 25 over 8. 25 over 8 minus 25 over 4 plus, I'll say 6 over 1, and we're gonna get a common denominator in a moment. So let's take this up here, because I want to have room for my answer down here. So 25 over 8 minus 50 over 8 plus 48 over 8. So that's going to be 23 over 8. Just checking that that's right. I believe that's right. I don't see any mistakes. Yeah, looks good. Okay, so that means that the domain is negative infinity to infinity, all real numbers. That's true for any quadratic function. And the range is starting at 23 over 8 and going to infinity. Okay, so what's next? For the following exercises, write the equation of each graph function. Okay. This can be a little bit harder if the coordinates you're looking for aren't totally obvious. This one's pretty clear. This is a 3, negative 1. And this is the vertex. So I found h is 3 and k is negative 1. It sure looks to me like the y-intercept is 3.5. So I'm going to say it sure looks like this ordered pair is 0, 7 over 2. Okay. So I'm going to use the vertex form, y equals a times x minus h squared plus k. And I'm going to plug in 3 for h and negative 1 for k. Okay. Now, in order to find out what a is, I need to plug in this ordered pair for x and y, because this ordered pair should match whatever the equation should be to be correct. Plugging this in should make the equation true. That's what a solution is. That's what a point on a graph is. It's an ordered pair that when plugged into the equation makes it true. Okay. So I'll put in 7 over 2 for y, and put in 0 for x. Okay. So I'm going to get 7 over 2 equals a times 9, or if I want 9a, same thing, minus 1. I'm going to add, well, I have 2 options. I can add 1 to both sides, or I can clear fractions first. So I'm going to start by clearing fractions, just because typically that is the more efficient way to do things. Okay, then I will add 2 to both sides, and you'll see why I hesitated. It kind of becomes redundant because I end up having to do a fraction anyway, but more importantly, that fraction reduces in a really nice way. So if I divide by 18, I'll get 9 over 18 is 1/2 equals a. So if I had added 1 to both sides, I would have gotten 9 over 2 on the left, and then when I divide by 9, I get 1/2 anyway. So in this case, maybe this wasn't the most efficient, but I think typically it's more efficient to clear fractions typically. So what did that find me? Well, I can go back and rewrite this equation, the vertex form, but with a plugged in. So for this one, y equals 1/2 times x minus 3 squared minus 1. And that's the vertex form for that graph. Okay. Yeah, it does not say it wants the general form. It just says find the equation. So we'll go with vertex form. And we don't need to distribute and all that. We'll leave it the way it is. This one, it sure looks like the vertex is at -1, 2. If I could write that neatly. And then the y-intercept sure looks like this is at 0, -1. Okay, good. So basically the same procedure. I used up all my room, though. Let's do this. Let's try to put it here. So y equals a times x minus h squared plus k. So h is -1, so y equals a times x minus -1 squared plus 2. So I'll have y equals a times x plus 1 squared plus 2. Now I can plug in the y-intercept. -1 for y and 0 for x. Okay, so I get -1 equals, well, a plus 2. Subtract 2 on both sides. And I get -a. So that means that y equals, or -3, sorry. A equals -3. So y equals -3 times x. I'm going to go ahead and write plus 1. I don't have to have this so explicitly in vertex form with the double negative. The minus sign is part of the formula, but the problem did not say in vertex form. So the form I use doesn't really matter. So while this is technically not vertex form, the question didn't ask for that, so I don't need to worry about it. I'm just writing it this way because it's less symbols to write, fewer symbols to write. So there we go. -3 times x plus 1 squared plus 2. That should be right. Okay, what's the last one? So a rocket is launched in the air. Its height in meters above sea level as a function of time in seconds is given by h of t equals -4.9 t squared plus 227 t plus 220. Find the maximum height the rocket attains and the time this happens. Okay, so basically what this is saying is if you were to graph out, and I know we haven't spent a whole lot of time with graphs of functions, but I'll just do a quick sketch and explain what's going on here. It doesn't say what the original height is. I'm going to assume that the rocket is at some height. It goes up and it goes down again. That was pretty bad. Okay, good enough. And then, kablooey, right? At the end, presumably. Or it lands. It doesn't say. All right, let's assume it's a successful launch of a civilian science-based rocket, right? So what's the maximum height? Well, that would be k. What's the vertex? What's the highest value? And if this is my time axis and this is my height axis, right? Then the and of course we're using h for height in this context. We want the x coordinate of the vertex for the time and the y coordinate of the vertex for the height. Okay? I'm using x and y because we're used to x being the horizontal, y being the vertical. We don't have to. T could be our horizontal axis, and h could be our vertical axis, but we're just used to x and y. I would assume most of you are more accustomed to that. That's why I say we. So what I want is, what is the vertex, essentially? Well, I can say that the x coordinate of the vertex, okay, this is going to be -b over 2a. Well, -b, that's this, -227, over 2 times a, which is -4.9. Okay, so do I want a calculator for this? Yeah, I mean, I guess I want a decimal approximation at some point, but I think I'll do this. I'll say 227 over 9.8. Does that reduce? Maybe not. I can write this as 2270 over 98, and then that reduces. What's 2270? So it's 1135 over 49. Maybe I'm getting a little bit too in the weeds here. Does the 7 go into 1135? So 43. No, it does not. Okay, cool. So that's as close as we're going to get. But maybe we do want a decimal approximation. So 1135 divided by 49. So 23.163. Okay, approximately, right? I'm rounding a little bit. So now I want what is the that's when. That's the when this happens, right? This is the horizontal. So what is the maximum height? Well, that's going to be the y coordinate of the vertex. That's going to be h of 1135 over 49, right? So this is going to be negative 4.9 times bigger parentheses here. 1135 over 49 squared plus 227 times 1135 over 49 plus 220. Now, I don't think we want to mess with these fractions, but I will observe that these two are going to reduce in kind of a convenient way. Okay, but do we want to bother doing that or just throw it in the calculator? I know I'm hearing some of you shouting at me, throw in the calculator. So I guess I'll capitulate. We'll just throw in the calculator. So negative 4.9 times 1135. Now notice I'm not going to type this in my calculator. Sorry, wrong tool there. I'm not going to type this in. I've already rounded this to 3 places. I'm going to type in the whole thing. If I'm having my calculator do it, let's not be extra lazy. Let's type in the whole fraction so the calculator has the exact value to work with, okay? And then plus 227 times 1135 divided by 49 is 220. Okay, so my calculator gives me 2849.031 approximately. Now I notice the problem doesn't say exact values only, and it doesn't tell me how to round. So I'm going to assume that rounding is acceptable because the problem didn't say not to. And this was in seconds, I believe. Yeah, and this was in meters. So this is the highest height, and this is how long does it take to get up to that height. Okay, so the vertex for parabolic motion will tell you that information.